Section 3.3, question number 5. Determine the intervals in which the function is increasing, decreasing. Find the values of the local maximum and local minimum. Find the average rate of change over the interval -2 and 3 to 3. So first I want to identify where the function is increasing and decreasing. So you can see the trend here is increasing, and then there is a local maximum at this point. And then the behavior is changing to decreasing, and we have a local minimum, and then it is increasing again. So I'm going to put some lines to identify the intervals. So the interval from the left is from -infinity to -2. The middle interval is from -2 to 3. And the last interval is from 3 to +infinity. So now I know that the function is increasing on the intervals -infinity to -2 and from 3 to +infinity. And it is decreasing on -2 to 3. Then we're going to find the local maximum and minimum. The function has a maximum of, the maximum point here, the local maximum is 1, and it happens at x is equal to -2. And it has a minimum of, the lowest point here is 6, 7, 8, -8, and it happens at x is equal to 3. So at this point right here. So this point is -2 and 1, and this point is 3 and -8. So that is the maximum and minimum, and both of these are local because those are not the highest or the lowest point on the graph. Find the average rate of change of the interval -2 and 3. -2 and 3 is basically this interval right here. So we want to find the average rate of change. So we're going to say the average rate of change is equal to f of 3 minus f of -2 over 3 minus -2. So I know that f of 3 is -8 minus f of -2 is 1 over 3 minus -2 is positive plus 2. So it's equal to -9 over 5, and that is the average rate of change. The table gives the annual sales in millions of dollars of a product from 2010 to 2016. Find the average rate of change of the annual sales between 2010 to 2011, 2011 to 2013. So the first one, the average rate of change is equal to, the sales in 2011 was 233. The sales in 2010 is 201 over, the difference in years is 1 basically, so it's going to be 1. So the average rate of change is 233 minus 101 is 32. So that is the average rate of change. For B, we need to find the average rate of change from 2011 and 2013. So we're going to say the sales from 2011 is 200, from 2013 is 263, and then the sales from 2011 is 233 over, the difference between the years is +2, so plus 2, so 2013 minus 2011 is 2 over 2, which is going to give me 15. And I forgot to put the unit here. The unit is going to be, of course, it's going to be $1 million per year. Per year. Same here, $15 million per year. At the start of a trip, the odometer in a car reads 20,736 miles. At the end of the trip, after 11.5 hours later, the odometer reads 21,372 miles. What is the average rate of change, or the average speed of the car traveled? That is the average rate of change, which is going to be the reading of the odometer after the trip minus the reading of the odometer before the trip over the difference in time, which is 11.5 hours. So that is going to be 55.3 miles per hour, or we could say miles per hour. But the unit is very important. Sketch a function that increases from negative infinity to 2 and decreases from 2 to positive infinity. So I'm going to graph the coordinate system. And now I know that change happens at x is equal to 2, so I'm just going to make a line here to help myself. I want the function to increase from negative infinity to 2 and decrease from 2 to positive infinity. So I could basically say here is the increasing part and here is the decreasing part, and it's going to be an absolute value function.